Lesson 3.4 introduces variables that can occur on both sides. We still follow the same routine that we have been in the previous lessons. However, it says that you may first collect the variable terms on the side with the greater variable coefficient. Although this is not a rule that always has to be followed this way, you want to get the variables together. But by putting them on the side with the greater variable expression, you reduce the work that needs to be done with negatives. So in this first one, the larger of the two variable expressions happens over on, or the larger of the two variable coefficients happens on the left side. So I'm going to go ahead and I'm going to collect the variables on the left side of the equation and the constant terms on the right side. Now I caution you to do this in two separate steps. As we continue to get more and more complex, when you combine terms too quickly, you lose some of the terms. So the first thing I'm going to do is I'm going to work on the variables. So I want to get the negative 2x off of the one side. So I'm going to add 2x to both sides. Now, in doing so, another thing that's very important is to keep that equality sign, that computating equality sign. It will keep things in order for you, and it's very, very important to stay neat and exact in your works here, in your work in these kind of problems. So the negative 2 and the positive 2 cancel each other out. I now have 9x. I still have my constant term of 19, and that equals the 55 on the other side. Now I can take care of my constant terms. I'm going to subtract 19 to get the constant terms together and isolate those variables. So I have 9x, sorry, oh, that's very ugly. I'm going to go ahead and rewrite my x entirely. 9x, and then 55 minus 19 is going to give me 36. Now usually we work vertically, but I have limited space here, so I'm going to transfer this over to a new column. We have 9x equals 36. I want to solve for a single variable, so I'm going to divide both sides by 9, giving me that x equals 4. Moving on to our next, my goodness, our next example, we're going to look at moving our variable. Now, if we follow the rule, I'm going to do this one two different ways. If we follow the rule they told us before, we would need to move we can move the 9y because it's smaller because it's a negative 9y. So I can go ahead and I'm going to add 9y, and that's a pretty crazy y. But we're going to add 9y to both sides, and I would have an 80 equals, and then we would have 15y. Now the problem with moving our 6y over to our, I want to do this in a different color here. The problem with moving our, if we would decide to move our 6y over to the 9y, then, oh, that wasn't a very wise choice of colors there. You can't see the white. If we wanted to move our 6y over by the 9y, in return then we would have to move the constant term over here. So we would have more steps. So we're going to just stay with the way that they had told us. I think I'm going to get a different blue this time. So I have 80y equals 15y. Solving for, oh, it stayed the pretty blue. Solving for a single y, 15 divided by 15 equals y, and 80 divided by 15. I can reduce that. 5 goes into both of those. 5 goes into 15 3 times. 5 goes into 80 16 times. That's the best I can do at reducing them. And because we're in algebra, we do not have to change that into a mixed number. I would prefer it if you would leave it as an improper fraction. 16 thirds, or 16 over 3. Y equals 16 over 3. All right, going to the next example, we're going to talk about some linear equations. And they do, sometimes they do not always have one solution. An identity is an equation that is true for all values of a variable. And then some equations have no solution. So I wonder what we're going to have in the examples here. We're going to have a one solution and a no solution. Again, use your rational, logical thinking when you're thinking of this. So the first one that we're going to have in example 3, we have a distribution that has to be done before we can go any further. 3 times x equals 3x, and 3 times 2 equals a positive 3 times a positive 2 equals a positive 6. Now, as I recopy the rest of the statement here, I get 3x plus 6. Well, yes, 3x plus 6 will equal 3x plus 6. And that could work no matter what we substitute in for x, because they are the same sentence. So for this particular problem, we're going to say it is always true. So all values of x, or many, or you can put all. Okay, that is an ugly many. Let's make that a little bit more legible for you. Oh, and it switched colors on me. And now I'll probably be in the darker blue too. Very strange. All right, to do the next problem, you'll notice that I have a single variable on each side. And then I have that we're going to add 2 or we're going to add 4, and it says that they're going to be equal. Well, if x has to be the same value, then they can never be equal if we're going to add 2 on one side and 4 on the other. Now, another way to do this is I'm going to go ahead, and I didn't catch that. I got so into working out my problems that I'm going to go ahead and follow the steps. Oh my goodness. And I'm going to combine my variables. So I'm going to do it on the left-hand side because that's where I want it on the end. So I'm going to subtract x from the right side, and then I'm going to subtract x from the left side, keeping that balanced equation. However, when I do that, x minus x would leave me nothing there, and x minus x would leave me nothing on this side, and now I'm left with 2 equals 4. Can 2 ever equal 4? No. So this is a no solution. So you have an all and a no. So example 4 continues with complicated equations. And we'll see what color we end up. I'm going to change to black so that we can see if we can make it through, and we'll see what happens here. So in this complicated one, I see that we have some distribution. Distribution always has to go first. So first step is distribution. 4 times 1 is 4. Oh, I have a gray colored now. 4 times negative x would be a negative 4x. We don't do anything here. The 3x would stay the same. That's going to equal another distribution going on here. Let's clean up that equal sign. So negative 2 times x gives me a negative 2x. Negative 2 times 1 gives me a negative 2. Now we're to our previous example where we have some like terms that need to be combined. So we'll leave the 4 here. A negative 4x and a positive 3x would leave me with a negative 1x, or we can just say x. Copy down what we did not have to do any simplifying for yet. Now I want to get my variables together. Is negative x or negative 2x the larger negative x is? So I'm going to cancel out my variables on the right-hand side. Do it by using balanced equation. It's an equation, so we're going to do some computation. I'm going to use the large equal sign. I have 4, a negative x plus 2x. Sorry, that was my fault. A negative x plus 2x is going to give me a positive x. Find the difference. Give it the one of the bigger the larger sign. So I have 4 plus x on the one side, and then on the other side, I just have my constant term of negative 2. And I have a little itty bitty bug that keeps crawling across my screen as I am as I'm recording this, so it's kind of freaking me out a bit. Sorry for the interruptions. I think I got them. So now we're going to go ahead and we're going to look at 4 plus x equals negative 2. Let's get our constant terms together, minus the bug. And I'm going to have a positive x equals negative 6. Again, you could substitute that back in to check your math, and you can use a calculator for that. Another complicated one, we're going to do another one, and this time we have some coefficients, or I'm sorry, oh my goodness. We are having some problems here on my iPad. It seems as though I've lost my connection, so let me go ahead and I'm going to pause and reconnect. Sorry about that. Okay, it looks like I'm recording now. I'm not sure if the recording continued while I reconnected with my iPad. But in this case, we have some distributors that are fractions. So to do that first, if you remember previously, we don't like to have those fractions that are distributors. So I'm going to get rid of that first. So to get rid of that, I am going to multiply by 4. By multiplying by 4, I lose that distributor that is 1/4. I need to do the same thing on the other side. Now, the only difference with this one is, I'm going to recopy here and show you a slight variation to this. All right, I have 1/4. Now, in this case, both of the terms that I would be distributing to are divisible by 4. So I can go ahead and I can do the distribution. So 1/4 of 12x, so 12x divided by 4 would give me 3x. And 1/4 times 16, or 16 divided by 4, would give me 4. And then on the right side, I have my 10, and then I can distribute my negative 3. So negative 3 times x would give me a negative 3x. Negative 3 times a negative 2 would give me a positive 6. Again, this is a more complicated sentence. So let's get our like terms together. When we go ahead and we'll do the variables on the same side, 3x is larger than a negative 3x. So I'm going to go ahead and I'm going to add 3x to both sides. That gives me 6x plus 4 equals 10 plus 6. Let's go ahead and do some simplifying. So I have 16 here, and I have 6x plus 4. Let's subtract the 4 from both sides. Running out of room here again. I end up with 6x equals 12. And if you can bear with me, I'll try to get my dividing by 6 to solve for that variable, and I'll just squeeze that in here. 6 divided by 6 gives me x, and 12 divided by 6 gives me 2. So in this case, x equals 2. We've got to the second part, the second goal, where we're going to solve some real life problems. So a video store, and this is a little dated, so I don't know how real life this is, but it charges $8 to rent a video game for 5 days. You must be a member to rent from the store, but the membership is free. A video game club in town charges only $3 to rent a game for 5 days, but the membership in this club is $50 per year. So which rental is more economical? So we're going to look at the video store and the video club. So we're going to put all their fees together. On the one side, we have a store rental fee and the number of rented. On the other one, we pay the club rental fee, number of rented, but then we also pay a club membership fee. So when I go to set up, you'll notice that the rented is our variable. We want to know when the membership is going to be more beneficial, or if it will be. So I'm going to go ahead and I'm going to fill these things in. the store rental fee was $8. That's going to be times by the number rented, and we don't know that, so that's going to be my variable. I'll let it be X. Now, the club rental fee we know is $3. We don't know how many we're going to rent again, but we also know when you're a member of the club, you have to pay a $50 club membership. So now we're going to get our variables together. So let's go ahead and subtract the 3x from the right, because the larger one was on the left. Equal sign, and I'm going to end up getting 8 minus 3x is 5x, and that is going to equal 50. Divide both sides by 5, and I will end up with x equals 10. See if I can squeeze that in there. So when we get to the 10, if you rent more than 10, the club is going to be more economical. But if you rent less than 10, you want to stay with the store rental because your fee is going to be your total will be slightly lower. So we compared them by setting them up to decide when the fee would be equal. The fee is equal when you have rented. Remember, our variable was how many we rented. When we've rented 10, the fees become equal. Now, the membership was a one-time deal, so you no longer have to pay that. So after $10, or I'm sorry, after 10 videos are rented, then you can go ahead and your club membership would be the wiser choice. Here they do, they have what we worked out as an equation. And then they also have where you're going to do a unit analysis instead, setting up it as a unit analysis. And they even made a table so that you could check your work. So the cost of the store, cost at the club, and so the store is always cheaper before we get to the 10 rented, but it's the same price when you have 10 rented, and then after that, the price for each video game is less, so the club becomes cheaper because you've already encountered the club membership fee. And that is the last example on lesson 3.4.